Hello, everyone. Welcome to section 10.6. In this section, we're going to be talking about determinants of matrices. So if you have a square matrix, you can find its determinant, which can be useful for finding solutions to some systems of equations and will come in handy a lot, especially if you start taking like calculus, like Calc 3, it comes up. And it also comes up, especially in, of course, linear analysis and linear algebra. It's a very important tool whenever you're working with matrices, especially when you're working with matrices separate of the context or separate from the context of systems of linear equations. So without further ado, let's go ahead and talk about determinants. So we're going to go ahead and start off by talking about the determinant of a 2 by 2. There should be an n there. So determinants of 2 by 2 matrices. So the determinant of a 2 by 2 matrix A, which is denoted as DET like this usually, is defined as, so if we have A is like some 2 by 2 matrix with entries like A, B, C, and D, then the determinant of A is going to be, so what you do is you take A and you multiply it with D for your first entry, so A times D minus, so that was the blue, minus you take B times C. So that's minus BC. That's the green. So that's the determinant of a 2 by 2. Fairly straightforward. You take the top left entry, multiply it by the bottom right, and then from that you subtract, multiplying the top right entry times the bottom left. So for example, let's say we wanted to calculate the determinant of perhaps a matrix A with some actual numbers. So like maybe like 2, 8, -3, 5. So the determinant of A is going to be 2 times 5, so 2 times 5, minus 8 times -3. And so that's going to be 10 plus 24. So the determinant of this matrix is 34. Okay. So if you know how to calculate determinants of 2 by 2 matrices, you can use something called Cramer's rule to find the solution to a 2-variable 2-equation linear system really quickly. So let's talk about that. It turns out that you can use Cramer's rule for bigger matrices. In fact, you can use it for, you can use Cramer's rule on any sort of size system. But for this class, I'm only going to have you focus on using Cramer's rule for 2 by 2s. So if you have a linear system, or a system of linear equations, and let's say it looks something like A times X plus B times Y equals some number R. So here X and Y are variables, and then A, B, and R are some numbers of some sort. And then the second equation will be CX plus maybe DY equals S. So here C, D, and S are whatever numbers. The solution to this system is, so the the x is going to be equal to the determinant of, you take these two numbers, r and s, and you put those as the first column of the matrix, and then you take b and d. Here, actually, let me put those as colors. So b and d. So you're going to take the determinant of that matrix over the determinant of, and if we make A and C green, it'll be A, C, B, D. So that'll be the x coordinate of your solution, and the y coordinate of your solution looks kind of similar. It'll be the determinant of, now this time you're going to have AC in the first column and RS in the second column, and that'll be over the determinant of the same matrix as the denominator in the x coordinate. So it'll be AC in the first column and BD in the second one. So if you're comfortable taking determinants, this is a really fast way of solving a system, a linear system with just two equations. So, and just of course to note, this works as long as, you know, that determinant of A, C, B, D is not zero, right? We just don't want to divide by zero. That tends to break things. So, but this rule works in every other case. So let's just look at a quick example of applying Cramer's rule. So we're going to use Cramer's rule to find the solution to the following system. It'll be like 2x minus y equals -9 maybe, and then we've got like an x plus 2y equals 8. So our x coordinate will be the determinant. Let's go ahead and use the same colors we did last time. So these were red, these were blue, these were green. So it's going to be the determinant of RS, so this will be -9, 8, and then it'll be the y coefficients, so -1, 2, over the determinant of the matrix of the coefficients. So this will be 2, 1, -1, 2. And so if we go ahead and do this, go ahead and calculate the determinant of the top. We have -9 times 2. So that'll be -9 times 2 minus -1 times 8. So it'll be -1 times 8 over the determinant of the matrix on the bottom. So it'll be 2 times 2 minus -1 times 1. And I think we do some simplification. This becomes -10 over 5. And that's going to be equal to -2. Okay. So that's the x coordinate. Now we need to do the y coordinate. So we'll have the determinant of, this time we have our x coefficients in the first column and our r and s in the second one. It's -9, 8. And then we have the determinant of, and it's the same matrix on the bottom this time. So actually we've already calculated this determinant, which is kind of nice. So the determinant of the top, we have 2 times 8 minus -9 times 1. That's going to be over, we already calculated a determinant of this exact same matrix. That's going to be 5. That's from above. And then I think if we simplify the top a bit, we get 25 over 5, and that is equal to 5. So the solution is -2, 5. So pretty nifty if you like calculating determinants more than you like trying to do back substitution or EROs, et cetera, et cetera. This is just another way to do it. Okay. I also want to talk about finding the determinant of maybe bigger matrices. We're going to talk about finding the determinant of a 3x3. And the way we're going to do that, turns out that you can do this, the same sort of idea, but to bigger matrices. And you'll kind of see what I mean by that. But let's go ahead and talk about 3x3s. Let's talk about the determinant of a 3x3. So the technique for calculating the determinant of a 3x3 matrix is called cofactor expansion. So for this, we use cofactor expansion. There's a reason it's called that. It involves a lot of strangely complicated math terms like cofactors and minors and blah, blah, blah. I'm not going to bother teaching that to you because it's not informative about the process. I'm just going to go ahead and teach you how to do it because I figure that the words are just going to be more confusing. So if we have a matrix, so maybe A is some 3x3. Let's give it some entries. So we'll do A, B, C, D, E, F, and B, G, H, I. So to start off with this technique, we select a row or column to focus on. It can be any row or column. And I'll give you a little bit of a tip as to which one to pick, because depending on which one you pick, it can be easier or harder to calculate a determinant. But it doesn't really matter for a 3x3. It all kind of works out the same. So to start, we select any row or column to focus on. For example, if we had that A matrix above, we could pick maybe some common choices are the top row. We could also possibly pick the first column. Those are the two most common ones, just because it doesn't quite matter which one you pick. So you might as well pick the first one. So this is some examples. Of course, you could also pick like this one, or if you really wanted to, you could also pick this one. Again, whichever row or column your heart desires. I'm going to go ahead and explain the technique for what happens when you pick a row, and what happens when you pick a column. It's almost identical, just a little bit flipped. So if you picked a row, you start by crossing out the leftmost column and calculate the determinant of what's left. So for example, if we were looking at our matrix A, so A, B, C, D, E, F, G, H, I, and let's say we were focusing on this top row up here. I'm going to put little pluses and minuses in this particular order. It goes starts with a plus, then minus, then plus, and we'll see why in a second. What you do, so we're going to cross out the leftmost column. So we're really focused on this entry here. We're crossing out this one, and we want to calculate the determinant of this in the yellow box. And what we do, so the determinant of that is going to be E times I minus F times H. And then we take that thing we calculated, the determinant of the thing in the yellow box, and we multiply it by A, because A is at the head of the column we crossed out. And notably, because A has this plus here and this plus here, plus times plus is positive, so it's going to be positive A. It's a lot of steps, but let's go ahead and keep going, and we'll see some examples. And once we start doing some examples, it'll get a little bit clearer what's going on. Okay. Once we've done that, then do the same thing for the next column. So again, this matrix. Just make my A's and D's maybe look a little bit different. I've confused myself many occasions by not writing my D's clear enough. Okay, so we're still focusing on the same row, but now we're kind of looking at the next column. So the next column is this B here. So we're going to cross out this column. Don't forget your pluses and minuses. I guess I should emphasize that the plus starts at the top, minus plus, and then plus starts on the left, minus plus. Okay, so we're doing this B, and we're going to be looking at the determinant of what's left. So we're looking at the determinant of like this D, F, G, I matrix. Okay, so it'll be D times I minus, and then F times G. Okay, and then we're going to take that determinant and we're going to multiply it. So that came from that determinant. We're going to multiply it by our B. And because B has this minus and this plus, positive times a negative is a negative. So this B is going to be, you're going to get a negative out in front of it. So this B came from the green and this negative came from the red. And I should color code the ones up here as well, so we know where they came from. Okay, and then the last step, or not the last step, but you do this again. So, and so on. So we do this one more time for the last column. A, B, C, D, E, F, G, H, I. Okay, so we're still focused on the same row. We've got plus, minus, plus, plus, minus, plus. And now we're doing the last column. So we're looking at this C column. We're crossing that one out, and we're going to look at the determinant of this. So the determinant of the box in the yellow, we get a D times H minus an E times G, right? And then we're going to take that and we're going to multiply it by that C, because that's what we were focusing on. And then if we look, let's see, a C's got the plus and a plus, so positive times a positive is positive, so this will be positive. So again, this came from the determinant of the box in the yellow. This C came from the header of the column we canceled out, and this plus came from looking at those pluses. So then, the last step, we add them all together. So the determinant of A is going to be, so the first thing we found was a positive A times E I minus FH minus B times AI minus FG. So that minus came from the pluses and minuses, the red ones on the side. And then plus C times DH minus EG. So that's cofactor expansion when you focus on a row. If you focused on a column instead, you would just cross out rows successively and do the exact same thing. And we'll look at an example of that in a second. But first, let's look at an example of the kind of thing that I just did, but with actual numbers. We can really get a feel for what's going on here. So let's say we wanted to calculate the determinant of a matrix that maybe looked like, let's do 2, 1, 3, 0, 4, -1, and then like a -8, 3, 5. Okay. So just like the general thing I did a minute ago, I'm going to go ahead and focus on the first row so we can see the idea that we just talked about in action. So we're focused on this row right here, and we're going to start by looking at the first column and crossing those out, and we're going to be looking at the determinant of that in the yellow box. And of course, don't forget your pluses and minuses. You don't have to write the pluses and minuses. You don't have to be making all these colorful diagrams to do cofactor expansion. I'm sort of doing it to illustrate the process. You don't have to write the pluses and minuses on your homework or anything. Okay, so the determinant of the thing in the yellow box is going to be a 4 times 5 minus -1 times 3. We're going to take that, and then the thing in the above the column we canceled out is going to be a 2, and that 2 has a plus and a plus, so positive times positive is positive. So this is going to be a positive. Okay, so we got that from canceling out that column. Okay, and now if we do the same thing, but with the next column, oops. So we're still focused on the same row. We're looking at this column here. We're going to cancel that out, write our pluses and minuses. And we're looking at the determinant of sort of this thing that's kind of been split down the middle by that green bar. And so if we do the determinant, it's going to be 0 times 5 minus -1 times -8. And then we're going to take that determinant we found, and we're going to multiply it by the thing in the header, so that's going to be a 1. And then the 1 has a minus and a plus associated to it, so negative times positive is negative, so this will be a negative out in front. Okay. And then lastly, let me make myself a little more room here. So we had a 2, a 1, a 3. 0, 4, -1, -8, 3, 5. So again, we're focusing on the same row. And we're going to look at this last column. We're going to cancel that out. And then plus, minus, plus, plus, minus, plus. And we're looking at the determinant of that thing in the yellow box now. And so if we look at that determinant, we get a 0 times 3 minus 4 times -8. We're going to take that determinant, we're going to multiply it by the thing in the green header, so that's going to be a 3. And then 3 has a plus and a plus associated to it, and positive times positive is positive, so this is going to be positive. Okay, then we add them all together. So the determinant of A is going to be, so the first thing we found was this plus 2 times that determinant thing, so this is going to be a 2 times 4 times 5 minus -1 times 3. And then it'll be a minus, right? So -1 times this. So it'll be -1 times 0 times 5 minus -1, -8. and then plus this thing right up here. So it would be a 3 times 0 times 3 minus 4 times -8. And that's the determinant. And all we need to do is simplify. And you can go ahead and do the multiplication and subtraction, the addition, whatever. I think once you simplify all this, you get 150. So the determinant of this matrix right here was 150. Okay, cool. Let's go ahead and look at an example of doing this, but with a column. So let's say we wanted to calculate the determinant. And let's say our matrix was something like -1, 3, 3, 2, 4, 1, 0, -5, 1. Okay. So let's go ahead and do this, but now let's look at what happens when we want to focus on a column. So I'm going to go ahead and focus on the first column, because why not? So if we do that, we're going to do the same sort of thing, just kind of flipped around a little bit. So we're going to start off by focusing on the top row, and we're going to cancel it out. And we want to calculate the determinant of what's left. So that stuff in the yellow box. So that'll be 4 times 1 minus 1 times -5. And we're going to take that and we're going to multiply it by the thing in the green circle, that header there. So it's going to be a -1. And then don't forget our pluses and minuses. So that green circle thing has a plus and plus associated to it. So positive times positive is positive. So we get a positive out in front. Okay. And we do the same thing moving down a row. Okay. So we're going to focus on the same column, and this time we're going to look at the middle row. We're going to cancel it out, and we're going to look at the determinant of sort of this thing here. Okay, and then we'll write our pluses and minuses. Okay, so if we do the determinant of that thing, it's going to be a 3. This 3 times 1. So that's 3 times 1 minus 3 times -5. 3 times -5. And we're going to take all of that determinant of the thing in the yellow box. We're going to multiply it by that thing circled in green, the header of the column we canceled. So it's going to be a 2. And the 2 has a positive and a minus associated to it. So that's going to be a minus. Okay. And then we move down one more row and do the same thing. Okay, so if we focus in on this same column, and now we're looking at the 0 and we're canceling this thing out. And we're looking at the determinant of what's in this yellow box. And I got my pluses and minuses. So the determinant of the thing in the yellow box is to be 3 times 1 minus 3 times 4. So all of that, and then multiply by the thing in the green header, that's going to be a 0. Interesting. And then the 0 has plus and a plus associated to it, so it's going to be positive. So notice that because this 0 is multiplied in front, it doesn't matter what number is in here. This thing's going to equal 0. Okay. And so here's the pro tip about picking which column or row you want to do. You want to pick the column or row that has the most zeros, because then if you pick something with a 0 and you know that you're going to end up circling it and you know it's going to end up going here, you're going to end up canceling out the whole thing. So you don't even really need to do this step. And we'll see an example of that in just a second. But this is going to end up being 0, right? Because it's multiplied by 0. So now we just go ahead and add all the things together to finish this off because we want to find the determinant. So the first thing we had was a positive negative 1. So this will just be, oops, wrong gesture. So this will be negative 1 times 4 times 1 minus 1 times negative 5. And then we got a negative, so minus 2 times that thing. So this will be a minus 2 times 3 times 1 minus 3 times negative 5. And then, as we discussed earlier, because this is 0 times whatever, this is just going to be plus 0. And then when we go ahead and simplify this out, I think we end up getting 15. Okay, cool. Let's do one more example because this stuff can be kind of hairy. Let's take a look at when we don't pick the first row or the first column for whatever reason. So let's say we want to calculate the determinant. And let's say that our A is 3, 4, 1, 3, 0, 0, and then 2, negative 1, negative 1. Okay, so you notice there are 2 zeros. They're both in the middle row, right? So we're going to end up wanting to focus on that one because, as I mentioned previously, it'll end up that when we do this, those zeros will mean that we don't have to do the elimination for some of those columns. So let's go ahead and look at that. So we do 3, 4, 1, 3, 0, 0, 2, negative 1, negative 1. We're going to go ahead and focus in on the middle column because it's got those zeros. It's going to be very convenient for us. And then we go ahead and start off by eliminating the first column. So we're going to focus on this 3 and we're going to cancel out the rest of it. And we're going to look at the determinant of what's left in the yellow box, not including the thing we're focused on, not including the thing circled in blue. Then don't forget our pluses and minuses. Okay, so the determinant of the yellow thing is going to be 4 times negative 1, 4 times negative 1. And then we've got minus 1 times negative 1. Okay. And we're going to take all of that and we're going to multiply it by the thing circled in green, the header right there. So that's going to be a 3. And that 3 has a plus and a minus associated to it. So positive times negative is negative. So that's going to be minus 3. Okay. Now notice that if we want to go ahead and do the other one, so if we kept going, let's say we wanted to go ahead and do the next column. And we're focused on this row right here, and we wanted to look at this column. Whatever you find to be the determinant of, I guess, the corner numbers, it's going to be 0 times determinant of the yellow. And so that, no matter what else happens, that's going to be equal to 0, no matter what. Because anything times 0 is 0. So, and the same thing happens if you were to look at this one. So our work's actually already done. The determinant of this matrix is just going to be this, right? Because it's going to be determinant of A is equal to the first thing we found. So that's going to be a negative 3 times 4 times negative 1 minus 1 times negative 1 plus 0 plus 0. They don't change anything. So then if we simplify this, it's a negative 3 times negative 5 plus 1. So it's going to be like a, or sorry, negative 4 plus 1. So it's going to be a negative 3. And that comes out to positive 9. So if you can pick a row or column that has more zeros, there's less work. So that's why sometimes you want to pick some that aren't just the first row or the first column. Okay, so that was calculating the determinants of 2x2 and 3x3 matrices. Cofactor expansion, it's a little weird, a lot of strange arbitrary rules that don't seem to come from anywhere in particular. But once you get the hang of them, they're fairly easy to implement, at least once you've had a lot of practice, like I have, I suppose. Okay, but of course, if they are giving you trouble, I'm always here to talk about them. I'm more than happy to sit in office hours and chat about determinants.